This conference will now be recorded.
So these sort of tools we have, sorry, this kind of types of networks we have seen. Okay, next, we have seen the OSI layers, different types of OSI layers we have seen. So how does the OSI, so what is exactly the OSI layers? So the OSI layers tells how the complete communication works between two different computers or whatever it is. If it is a server to normal user computer, or if it is a normal your mission to the Google server or whatever the internet resource, or your mobile phone to internet resource. It might be whatever the internet resources like Facebook, Google, whatever you're trying to reach out the internet, right? So how does the communication works? Okay, what was the process behind that? Okay, so that the complete flow we have seen. So what's so we have seen application layer, presentation layer, okay, session layer we have seen, and what is the next layer?
Transportation layer.
Then
network layer,
okay,
data link layer,
physical
physical
layer.
layer.
Okay, so what happens in an application layer?
It will give us the address like.
So user is interacting with here. This is the user, and user mission. This is the user mission computer A. Okay, computer A, and he is connecting to the internet via HTTP or HTTP. Okay, is connecting to. So application layer responsibility is, so it is having a residing. It is having a Chrome or any of the interface. So it provides the interface to your internet. Interfacing means something you need a in between you one person to interact with the internet. So that's why you're using an application layer. Okay, correct. So example like so if you want to communicate any of or if you want to reach out to some place, for example, I have to reach out to Dubai. So I wanted to go Dubai. So I have to use some interface, or I have to use some media to reach out this Dubai. So the same way you need some interface to reach out to the internet, right? So you cannot use Microsoft Word, PowerPoint, right, in order to reach the internet. So you cannot use, right? So you have to use some browsers. So you have to use some browsers like Google Chrome, in Firefox, or whatever. This kind of browsers you have to use, and you have to reach out the internet. So for that, so you are using the protocols. You have a set of protocols again. So these are the protocols involved in the application layer. Okay. So then the application layer, what happens in the presentation layer? The whole data, whatever the request you're typing www.google.com. So that request will be application layer to present. It will come to presentation layer. It will be converting into. It will perform a encoding. Something. It will be a machine understandable format. So it is something we can say as it is some symbolic representation. All your requests will be converted into your encoded. It will be performing into some numbers. That's a encoding performing. So encoding is always encoding, and after that there will be another action called as encryption. Okay. Okay, so encoding and encryption will be performing on the
presentation layer.
yeah. Okay, so yeah. So after that, the present encryption will be performed. So after an encoding encryption, so encryption is something. So this data has to pass in a secure manner. So that's why you're performing some encryption. So encryption is something. So you have to add some public key and private. I'll discuss that later part, encoding and encryption. Okay. So the next one is the session layer. So we already discussed the session layer is something creating a session between you and so your computer and internet. It might be a Google server or whatever it is, Google server. So you have some session ID created between Google server and you. So you have every time whenever you connect to Google, so there will be a one particular session ID will be assigned to your communication. Right now I am communicating to you with a one particular session ID. Once if I close it, so my session ID will be closed. And again, if I start, there will be a new random session ID will be created. Okay, I'll show you that. So the session IDs in the labs, we will see the session IDs and all we'll see. Okay, now see, so here the session layer responsibility is complete creation of a session with a internet resource or whatever it is, and manage the session and close the session. So that is the session layer responsibility. Now the transportation layer will be, now what the transportation layer will be, so here you sent a google.com, so that information will be divided into your in the form of chunks, the whole data. This is the whole data from the presentation layer will be divided into a like this. So this is called as a segment. Segment 1, segment 2, segment 3. So here you're adding a TCP header or UDP header. So mostly we'll be using a TCP header because we'll discuss why it is. Okay, TCP. We are adding a TCP here. Okay, so once you add the TCP, transmission control protocol, so why this transmission control protocol is used? So just in one word you can say as, so it will be helping to, it's like a media. So as I said earlier, so you wanted to reach your destination, so you must need a one specific media. Like if I want to reach my location, I need a bus, or I need a car, or so I need some vehicle to reach my destination. The same way here, you need this transmission control protocol. And the next layer will be the network layer, where you're adding the, so you have the media, you have the vehicle now, so, but you don't know the route. So you will be specifying here, this is now it becomes a packet. Once it reaches to the network layer, it becomes a packet, and this is a packet 1. And you will be along with the TCP header. Okay, TCP header, you will be adding the IP header here. Got it? So IP header you're adding. Now this is the packet contains the data, TCP header, IP header. Okay, like that every packet will be. So what happening here in the IP header, you will be adding the route. You'll be adding the route to reach the destination. So for example, I wanted to reach Google now. So what is the best path to reach the www.google.com? So that is the IP. That is the IP header. Okay, and then it will be coming to the data link layer, where the data link layer, it will be converted as a frame, and it contains data. I mean, we can call it as a frame. Okay, so the complete called as a frame. Now it is a data, TCP header, IP header, and then you will be adding a Ethernet address. Okay, now it becomes a frame. Okay, so Ethernet contains the physical address of the device, not a logical address. So physical address is something, your mission address. So where you're sending, what is your source IP, source mission details. Okay, so that will be happens here. Okay, and finally it will be converted into your zeros and ones, zeros and ones, and will be transmitting to via what? Any of a ISP. For example, I am using Reliance or Airtel. So this information will be passed to Airtel or ISP and then reach to the google.com. So now the approach will be completely from the bottom to top. So zeros and ones will be become frames, frames become a network, like a packets become a segment become a finally the actual in the presentation layer they will be performing the decoding. So you have performed here in the encoding, right? So in the receiving end, so you'll be performing a decoding, and then finally after a decoding of your data, you will be getting an actual request. So server receives that, so you want this information. So and then again it reply, then again it will go to the bottom to top, sorry, top to bottom approach, and then it will go to the. So this is how the process, this is how the communication works in any of the computer to computer or computer to any of the internet resources or whatever it is. So different sort of protocols works here. Application layer, HTTP, HTTPS, SSL, or TLS, or different sort of. SSL is something with the older version, and we can say SSL. And now, right now, we are using the TLS. TLS is the next version of SSL. So there's no much differences. There is just a few changes in the SSL protocol. And the upgraded version of SSL is a TLS. Okay, there is no much differences, but just a few additional features has been added. So other than there is no differences. Okay, so I hope you guys know what is the HTTP, what is the HTTPS. Okay, HTTP is something hypertext transfer protocol. So like for example, so you wanted to access any of the website, so you're using the HTTP or HTTP. Now we are not using HTTP, mostly we are using HTTPS. HTTPS is something secure. We can call it as a, even we can call it as a TLS. Okay, every information you're sending will be going. For example, if I'm sending some request to my computer, so where it will be adding internet. So and I'm sharing my Gmail, I'm connecting to Gmail and I'm sharing the passwords, everything. Okay, in between somebody can sniff your data. Sniff means catching. So somebody, a hacker or somebody, for example, one example, if so my Wi-Fi router, so instead of my Wi-Fi router, I'll be giving as my system gateway is something, how can we say, let me tell you this way. For example, so here is my system and here is my friend system. So we are using one Wi-Fi router in my room. So what happens, this guy is connecting to the router and reaching to the internet. So he has login is net banking. Okay, he has login net banking and he is trying to connect. So he is giving a custom ID password. Is giving a custom ID and password, and this will go via router to the internet banking. So for example, if I'm using normal HTTP, so there is no any usernames and passwords will not be encrypted in a HTTP. So what happened, what I will do is, so instead of router IP address, I have also connected to another router, or I'm using a geo or any other thing. So I'll configure my system as a router. So what happens? So all the internet, instead of traffic, instead of going to this router, so it will go via my system. So my system, it will go to the internet, because I have another thing is connected. I have another router is connected, or I have another service provider is connected. So I'll pass on all the traffic to my system. So what happen if I'm passing all the traffic via my system? So all the usernames and passwords he was giving will go via my system. So I will capture all his net banking username and password. If you are using a HTTP, but nowadays we are not using any HTTP for any of the banking sector, or most sensitive even Gmails, Facebooks, or whatever it is. We are not using HTTP because the passwords will not encrypted. Okay, so whatever username, if you are typing username, means when you capture, okay, when you capture the packet, data packet, username is there as Narendra means Narendra. Password is password means password only. Okay, if I type like this, it will be like this only, sent to the internet. So somebody can capture these details. So if you are using HTTPS, that is the secure. This is the no secure. This is just HTTP. Okay, there is no S. S means secure layer. So your username and passwords will be encrypted. So encrypted means nobody can read the data other than the destination. Okay, other than the net banking server, HDFC means they can only able to read your username and password. So if somebody comes and try to sniff your passwords, sniffing in the sense steal your passwords, okay, or capture your passwords, probably they cannot, they should not, because it is impossible to get the password if the passwords are encrypted. So it is a very difficult. Once the passwords is encrypted, so encryption will be using a different sort of algorithms, DES 3DES. Okay, like this, they are a very complicated the encryption algorithms. They will be doing a lot of, it's a big process, it's a big thing. So that is a, so where we went. So that's how HTTP, HTTPS, that's the difference between HTTP and HTTPS. So all your usernames, passwords will be transmitted in a secure layer. So this secure layer only, so your data will be reached the internet. So in this secure, so it was secure, nobody can see. So that's how the data will passes. So that's why it's a HTTPS. Securely you are passing the data. So you must have to know the protocols, this HTTP and HTTPS. So HTTP is a protocol, is a user for web request, all these things. So even HTTPS also the same, but it was not a secure. The port number is 80 for this, and HTTPS is a 443. So remember this. This is very important. Protocol and the port number. Protocol and the port number. HTTPS is a 443. HTTPS is a 8. So this was a very important. You have to remember this, and you have to know about what is a HTTP and what is a HTTPS. Even you can say HTTPS as a SSL. So SSL is equal to the HTTPS, secure socket layer. So HTTPS is equal to SSL. It's the same port number, 443. Secure socket layer. Got it? Any questions? Any questions? HTTP, HTTPS, SSL, TLS. So SSL, there was a few features has been added. in the version. So there will be SSL version 2, version 3, like that. So now we don't have any SSL, we have a TLS. So SSL next version, SSL we have a different versions are there. I think the V4, V5, like that. So there will be a couple of features. Every version there will be a few features will be added in terms of security, and then they will be releasing. Lastly, we have the TLS. Okay, TLS we are using. Okay. So any questions on HTTP, HTTPS, SSL, TLS?
Excuse me, Narendra.
Yeah.
Hello.
Yeah. Tell me.
Actually, sometimes even in HTTPS also sometimes we are able to see when changing the password or username. That is why, and
Yeah.
in which condition we are able
You,
to see.
you cannot see SSL or SSL certificates. You can see, but you don't see anywhere in the
Okay.
when you're to access a website, you don't see TLS or something. So it's just an
Okay.
version you can see, but when you're trying to access any website, you must have to add HTTP or HTTPS. So, but for in any of the internet resource, you should not use. There is no any HTTP mechanisms. Like so, earlier in the 2010, 2012. So when we got a Gmail, when we have the Facebook, so that time we have HTTP. There is no security, but later, so there will be converted into say HTTPS. It's a purely secure communication. So you can see most of the websites you can access by HTTPS, and SSL TLS is something you should not see, but you can see SSL certifications. SSL certificate means if the company has to take a SSL certificate, so they must have to take a SSL certificate. SSL means both that also means, for example, if I host any of the website, so I must need to take one digital certificate saying that this my website is authorized. Okay.
Yes.
So there is one company called the CA, or I think the C or something. So they will provide these digital certificates. So you can just go to if
Yes.
you're where here. Yeah. So you can see here the connection is secure, and learn more. If you click learn more, and you can find here there will be a digital certificate. Okay. So see here, you can see here the certificate. Your information is a private when it is sent to this site. And you can see here the certificate and issued by who issued the certificate of information. Okay, and who issued to company GoToMeeting and issued by CA. Okay, this one. And so you can find the details of version, serial file, and everything you can find. And the certificate is okay. It has to be valid. So that's all.
Okay. And one more, you told that something TTL, right?
TLS.
SSL is the certificate. That what about TTL?
Next
Or
version of TLS. Next version is see SSL have a additional features has been added, and there is no more SSL.
okay.
It is
Oh.
purely instead of changing the version name, so they have converted into a TLS.
Okay. Thank you.
So keep it. Remember, this is an important question, and this you have to so kind of interview question. What is the HTTP, HTTPS, and TLS, and the difference between these three and the port numbers? These are important. So it has to be even when you are working on. So there is no any. You cannot see when somebody is trying to access a website. You should not see HTTP or HTTPS in the logs. You will be seeing the port number. So based on the port number only, you have to identify what type of protocol it is. So any of the device logs, when you are analyzing some incident, you can only see the port numbers. You should not see any protocol and everything. So so based on the port number only, you have to identify which type of service it was. Okay, so next one we are going to discuss TCP.
Alice, the port number is to be a constant, right? It can't be changed.
It should not change. It is a the number should be
Yeah.
same. It's a service, right? See, a protocol is a service. So every service will be identified by any of the server. For example, the Google has been received the port number of 80 or a port number of 443. Then the Google assumes that this is the web request. Okay. If there was another service called as a SMTP, okay, that is a port number is 25. If any of a person is trying to access with a port number of 25, then that is the, so for your you have an email server, Gmail, for example, Gmail. If you are trying to request a Gmail server with a port number of 80, so you cannot access, because the Gmail server should not identify what is this port number. So Gmail server only can accept the port number of 25. Other than it should not, other than it won't accept any. It cannot identify, because the Gmail is responsible for email communication. If you're sending a web request, so it doesn't do anything. So it can identify only the port number of 25. So based on the port number only, every service will be identified. So I have another DNS servers are there. DNS service, you have to request a DNS service with a port number of 53. If you are not sending, if you are sending some other port number, the DNS server will not accept your request. It will not provide the DNS service. Okay, so that's why every service or every service will be identified based on the port number. FTP, file transfer, where file transfer servers are there. So to understand how does to get the data from the FTP, you have to use a FTP called protocol number called as a 20 for uploading, 21 for downloading, kind of 21 for 20 for downloading and 21 for uploading. So these sort of things. Okay, sorry, FTP cannot use 2021 for upload and download. So there will be a two set of, will discuss. There will be a control data control information will be exchanged, and data information will be exchanged on another port number. We'll discuss that. And now, so we'll be going to discuss the TCP and UDP protocol. So before going to the UDP, so TCP is the biggest concept, and mostly we'll be using a TCP in a regular data transmissions. So only few cases like a UDP, only few cases in a real-time environment like a video conferencing. So these kind of cases we'll be using. Otherwise, for most of the 90% of the application, they're going for a TCP application. Why we are using a TCP? What conditions made us to use TCP, transmission control protocol? So the first thing is it will be using in a transportation layer, right? It will be using in a transportation layer. So now, so first first point of TCP is it is a connection oriented. Connection oriented. So what do you mean by the connection oriented is, I have this device. So I wanted to reach the Google server in the internet. So this is the Google. So this is the internet. Via internet I have to reach. So first, what I'm going to do is, so before sending, so I cannot directly get the data from the Google server. So I cannot get a direct data from a Google server. What I'm doing is, first the TCP protocol will do what it will do is, it sends a one packet called as synchronization. In short, we can call it as a sync. Okay, it sends a one synchronization packet, and now, so this is the first packet. The first packet is a synchronization packet. Then the Google server will receive this packet. Okay, will receive this packet and sends a syn acknowledge to your computer. So this is your computer A, and this is the server. Okay, this is the first request, and you got a second request. So along with the second request only, server also send its own synchronization packet, like how the computer A sends, right? The same way, the server also will acknowledge to this computer A synchronization packet, that is the SYNAC, along with the another sync packet, with along with the server's own synchronization packets. Got it? So the first packet is synchronization packet, that is the one packet from the computer A, and the server. The server receives that. Server has to acknowledge. If the server is not acknowledged, means the server is not ready to, server is busy, or server is not be able to transmit the, server is not able to give the data. If the server is not accepting a sync, if the server is accepting, so whenever you try to access a Google, you should not see any issues, right? Whenever you try to access a Google, you'll be getting a web page from the Google, right? Until unless your internet is down or any other worst cases. So otherwise you'll get a web page from the Google. So that means you'll be getting, so before that happens, so this is the background process. So Synax, the server will send a Synac along with the same packet. It also send it's a server's own synchronization packet, like how the computer sent. Now this computer also has to send, acknowledge to the server sync packet. This server sync packet has to be received, right? Means, so what it is saying is, first you are saying that computer A to the server, hey, I want some data from you. This server will be responding to you that yes, I am able to provide. Along with that, you also confirm to me you are also able to receive the data. You can also able to receive the data. Yes, I am able to, I should ready to, so means I should ready to accept the data. It is asking you should ready to accept the data. That is a synchronization packet, and the computer will be yes, I am able to receive the data. So that is a acknowledgement. So this is the first packet, and this whole process is the second packet, and this is the third. First packet goes from computer A to server, that is the synchronization packet, and server will be responding to you with the SYNAC, that is the second packet. Along with the server's second packet, it is also send the server's own synchronization packet, so asking that, hey, are you ready to take the data from me? Oh yeah, the computer is reply to you saying that yes, I am ready to take the data from you. Okay, that is the TCP three-way handshake. Three-way handshake process. So first, before connecting to any of the device or any of the things, the TCP must perform this handshake mechanism. Okay, so that's why it is called as a connection oriented. So what is the handshake? See, usually if you go to any of the corporate environment, so before you're starting or before you're talking to someone else, what do? So you first do the handshake. You first do the handshake with them. You just give the handshake and then start conversation, right? So the same way here, before the server and computer try to exchange the information, or your computer is getting the data from the server, first it performs a handshake mechanism. So again, while we are performing the handshake mechanism, there is a lot of other factors are there. So means, so what sort of protocol we are using, I mean, what sort of how much data has to be transmitted. So this kind of information, it's a kind of synchronization between you and your server. So you have to establish the synchronization between you and your server. Synchronization is something. What do you mean by the synchronization again? So for example, you and your friend are there, so you must if you have to be stay in your room, you both guys have to be understand, means you both have to be synchronized. Okay, so then only you will be able to stay in one room. If you're not synchronized, means if you're not understandable, so probably cannot. So the same way, the computer server must agree couple of things, like what type of data transmission has to be done and what sort of how much information will be transmitted every packet. So these kind of information will be, it's a data negotiation will be happening in a TCP three-way handshake. It's a kind of control information exchange. Okay, control information exchange, like the packet length and other things. Okay, that's why we are going for a TCP three-way handshake. Once the TCP three-way handshake is done, so then you start transmitting the data. So now that complete TCP three-way handshake done, okay, then you started sending the data, or the server started sending the data to you. Got it? You got it? The TCP three-way handshake.
Yes.
Okay, so you are here and your computer and your internet resource, your internet and the server. Okay, so this is a server. Sync, synac. So sync is your packet, this route, this direction it will go, and this direction is a synac along with the synchronization packet of server. This is second packet, and the third packet is first, second, third packet is you will be sending a synchronization. You're sending acknowledge to server synchronization. This server synchronization packet acknowledge. So then started exchanging of data. So this is the data exchange between your computer and so that's how the TCP three-way handshake works. Okay, once data transmission has been done. So what is the next thing? Hey, I'm done. Your computer, for example, you have downloaded a PDF from the Google server or any of the server. Okay, your data transfer is done. What is the next process? Next process is TCP four-way termination. TCP four-way termination process. Again, this is the process. What happens in the TCP termination process? You'll be sending a synchronization packet. You'll be sending a finish packet to computer A to server. Okay, it will acknowledge. Okay, it will acknowledge to your finish packet, acknowledging in the sense accepting your finish. Yes, I have completed. You're saying yes, I have completed to server. Okay, server is responding to you. Yes, okay, I'm fine. Then server also sending another. This is a third packet, not a second packet. It will not come with the same packet. It will come with the third packet called as a. It will come as a third packet. It will also send from my end also. I have completed the data sending finish. So both the sides it will send a finish packet, and this one okay. Yes, acknowledging. So first is a finish packet from your side to server. Server is acknowledged, and server also send finish packet, and you have to acknowledge the server's pin packet as well. So that's how the four-way termination, it will be termination happens from both the sides, your computer side and the server side. So that's how the four-way termination will be happens. For example, your data was downloading, okay, in the browser, you're using a browser. Suddenly you close the browser. So what happened between your server and your computer is, so your computer, once you close the session, so automatically there will be one packet will go to your server. That is the RST, reset. That is a forceful termination of your connection. So the pin is the, so you're intentionally saying it was done. If I have closed forcefully any of the website, any of the tab, or if I'm trying to download in between, I have internet is down, or I have closed my browser accidentally, so it will send a reset. That is a forceful termination to your server. The disconnection will be happen to your server with forcefully. So any questions? So we have seen 4 packets: sync, synac, sync, ACK, pin. Sync means synchronization, ACK means acknowledge, pin means finish, RST means reset. We have seen on what cases we have seen all these flags. Got it? So that's a handshake mechanism. Okay, that's why we call it as a TCP is a connection oriented. It is a connection. TCP is a connection oriented. We have to perform every time handshake. First point is connection oriented. Connection oriented means you have to perform TCP three-way handshake every connection. Okay. Next point is it provides a retransmission of packets. Okay. So what do you mean by what is the retransmission of packets? So here I'm sending a data. So the data contains 10 packets. Okay. So if something was failed in between, if some data was failed, okay, when it is reaching to the receiver has to receive, right? Okay. So if any of the packet, if these packets has been going packet 1, packet 2, packet 3, so if any of the packet has been not reached to the receiver, so the TCP's protocol responsibility is to retransmit the packet 1. For example, I have sent 5 packets. The 5 packets, packet 1 received, packet 2 received, packet 3 received, packet 5 received, but packet 4 has not received. So the receiver will wait for a packet for some ideal time will be there. If there is no packet 4 has been received after ideal time, the pack. So how does again the process again? So whenever you send a packet, I already discussed. So whenever you send a packet, there will be an acknowledgement, right? So here I am sending a packet 1 I sent, P1 I sent to you, I sent to a destination receiver. So for example, there was a one image is an example. Okay, so I sent that the image contains the 5 packets. Okay, so first packet has been received by the receiver. Okay, the second has been received by the receiver, and whenever it is received, it will send an acknowledgement packet. Okay, P2 send acknowledgement packet has been sent by the receiver, and sender has sent the P3 packet. Receiver receives the P3 and sends the acknowledgement, but P4 has not sent, P5 has been sent. So what the receiver will do, receiver wait for a P4 packet for some time, and then will inform to the sender that I have not received the P4 packet. Okay, this packet is missing. Then it sent, this sender has sent, but somewhere in between, while transferring of data, it has been corrupted or it was been dropped due to network issue. Okay, the sender will send back again. The sender will hear from, or another case, if there is no acknowledgement from the receiver for P4 packet. Okay, it has to receive, right? Every packet there will be acknowledgement. Packet 1 acknowledgement received, packet 2 acknowledgement received, but P4 it doesn't receive any acknowledgement, so something wrong. So P4 has not reached to the receiver, so it will do the retransmission of packet. So that's how it will send the complete all packets. Okay, that is the retransmission of packets. That's why it is a more reliable. TCP is a more reliable because it is performing a handshake mechanism, and it performs retransmission of packet in case of if the packets has been lost. But when you see the UDP, okay, when you use a UDP protocol instead of TCP, so what happened? So UDP is not a connection oriented. It doesn't perform any handshake. It doesn't perform any handshake mechanisms to communicate any of the devices. Okay, and this another thing is it doesn't do any retransmission of packet. Okay, it cannot wait for until all the packets reach. Okay, for example, if you are using the TCP in a video conference, just imagine. Okay, I'm talking. Okay, I'm talking. For example, hi, hello, how are you? I said in the video conference. So what happens? So it creates a 10 packets as an example. What happened in between? 2 packets has been lost. Okay, so what happened in the TCP case? The TCP will be wait for another 2 packets until reach the all the packets reach the receiver, then only the complete image will be reconstructed. Okay, complete data will be there, or complete voice will be visible, audible. Okay, just imagine if you are using in a video conferences, and if something you're talking and it was not audible, and the TCP if you use the TCP and there will be 2 packets has been lost and it will be waiting for another packet, what happened? The video conference, it is a live streaming is happening. The 2 people are communicating via video. Okay, if the for the 2 packets it is waiting, what happened? Your image, you will be completely blur. Means the complete video conference will be hold for a second, 2 seconds. So that will not happen. So that's why you are going for the UDP. UDP, what it will do is, so it will not wait for any of the packet. So for example, 10 packets it went sent, and 9 packets has been received, another packet drop, means you see a little blur, or you see a little disturbance in the voice. Like, hi, I said hi, hello, how are you? You may miss hello. Okay, or in the hello, you properly will not audible. You'll not audible the OIs properly. Otherwise, everything is fine. If you use a TCP, then the complete video will be passed. It will stop it for a time, and then all the packets receives. Then you start getting again the video. Okay, your network is poor. For example, your network is not that much good, and you are using a TCP, then gone case. So you cannot do the video chatting at all, video conference at all. So that is the difference between TCP and UDP. So UDP should not do any retransmission. Okay, but why the TCP is good? So most of the cases, most of the applications. So for example, if I'm sending some data to you, www.google.com, one packet has been missed. Okay, so what happened if you use a UDP? So you lost some data, and the server cannot understand what you sent. Server cannot understand what you sent. So that's why we'll be going for a TCP. TCP will wait for that packet, and TCP will the receiver will wait for the losing packet. Once the complete all the packets has been received, and you have the complete request, complete information will be there. Okay, so that's why the TCP is most of the application. Even if you are downloading some data, okay, even you're using downloading some data, and if the packet has been lost, means you will be losing some data. If you use a UDP, in this case you'll be getting the data with the partial information. If you use a TCP, you will get the full information, because if the packet is lost also, it will wait for that lost packet, and finally it will receive it, and it is a full-fledged complete information. Okay, got it? Another case, TCP is slower. Why slower TCP? Because it wait for a packets. It wait for a, once if it is a delay, if there was some network issue, it wait for another packets to reach all the packets reach to the destination. It will wait until all the packets reach to the destination. Okay, for example, if you're downloading a file, so once you click the file, immediately the file will not download. The PDF will not download. So you have to wait for some time. Downloading is happening, because downloading is all the packets are downloading to your systems. All the packets are reaching to your device. Okay, so that is the TCP. Okay, and so that's why it is a slower, and it will be sending the packets. So for example, so here all the packets, if I'm sending a packets, so the data, so 5 packets I sent. So all the 5 packets, okay, this is an internet. Okay, this is internet. All the packets will be traveled one single route to reach the server. Okay, okay, one path. You have 4 paths. For example, to reach the server, you have 4 paths to reach the server. This path, this path, this path, this path. So the TCP will select the best path and go with that. All the packets will go with the same path. But UDP is not like that. Packet 1 go here, P1 go here, P2 go here, P3 go here, P4 go here, and finally reach the server. Okay, just a moment. So any questions on this? So how the packet will be traveling? So you understand, right? So if the TCP is, so it chooses a one selective path and travels all the packets from this network. But UDP is not like that. It chooses a different path. Okay, so the advantage here is, see, suppose this complete network is, the complete route is very congested, like a very traffic path. Okay, in between there was a huge traffic, means there was a less bandwidth here. So all the packets will go slowly. Like for example, so if I'm going from my place from Bangalore to Nellore, what happened? There will be two routes are there. So one route is always, some roads are not good and little heavy vehicles are there. Vehicles will be more. But another route is there. But that road is good, but distance is more. So what you have to calculate? Time you have to calculate. So the time, so this was a good. So I will be consider, this is the highest kilometer. This is a 450 and this is a 400 kilometers. But it will be, I'm reaching 8 hours this, and I'll be able to reach 7.5 hours. So still I can prefer 7.5, right? So I can be able to reach this, and this is like a traffic is more. Okay, all these things are there. So if you choose that path, so all the packets will go this path and then finally stuck here. But UDP is, one packet will go like this, one packet will go like this, one packet will go like this. So all the packets will go like this. So it was not a sequence manner. The packets also, it will come here like P4 first to come from UDP case, and then P3 will come. Wait for all the packets to, it will not wait for all the packets to reach. So like a video conference, right? So it will be happen, whatever the package was coming, it will be processing. But TCP is not like that. The first packets will be coming P1, all P1, P2, P3, P4, and every packet comes, and then it'll be, information will be finalized. Like information will be, you can see the information. Got it? That is the TCP versus UDP. TCP is the connection oriented and UDP is not a connection oriented. It doesn't perform any handshake. And TCP will be, so whenever you send any packet, whenever you send a packet to receiver, it will send an acknowledgement. But UDP, there is no acknowledgement process at all. So TCP, whatever you send a packet, there will be, from the receiver end, receiver has to acknowledge the packet, send and acknowledge to the sender, saying that, for example, I am going to my hometown. So first what I'm doing, I'm calling to a parents and then I'm informing I'm coming. Okay, so from where I'm starting, from Bangalore, my friend room. Okay, then I'm reaching to my hometown and I reach my home. Then I call to my friend saying that I have reached the home. So that is an acknowledgement to your friend. Okay, that is a TCP. But UDP, there is no acknowledgement. Okay, so that is the TCP. TCP always use acknowledgement mechanism. If there is no acknowledgement received in a TCP, if you have not received, if the server receiver has not sent acknowledgement to sender, the sender will retransmit the packet. Okay, what if sender assumes that the packet has been lost. Okay, if the receiver has not acknowledged the not send and acknowledge to sender. Okay, if I'm sending one packet to sender and the sender, there is no reply from the server, my assumption is the receiver has not received the packet. So my assumption, I should send one more, the same packet I'll retransmit. Okay, got it? So that is the TCP case. But UDP case, if the packet went or not, it doesn't matter. Just send a packet to receiver. It doesn't wait for any of the acknowledgement, or it doesn't send any acknowledgement. So TCP is slower, right? Because it is sending a synchronization packet and it wait for an acknowledgement packet. Okay, and then second packet, like there is a, every time you have to send the acknowledgement packet, so it is a slow process. But UDP is not like that. So UDP is faster. So there is no acknowledgement, sending a synchronization, sending all the packets, and no need to wait for anybody, just sending a packets, that's all. Okay, no retransmissions, nothing. Okay, so that is the TCP versus UDP. So if you understand, so you have to understand the handshake mechanism first, and then handshake termination process and the differences between TCP and UDP. So tomorrow we'll see the header part of IP header and TCP header. How does the header looks? So you're adding a data, you're adding a header to every time when you're sending a packet to the internet. So you will be adding IP header and TCP header or UDP header along with the data, right? So that we can discuss in the next class. So for example, I'm sending data. So this is a computer and this is a server. I'm sending the data. So this data along with the data, what you are adding, TCP header, UDP, or TCP or UDP, depends on the type of application, and IP header. So we'll see that why we are going for, so what is the inside of TCP header, what is the inside of IP header. Header part. So hope you understand TCP connection oriented, connection plus. Handshake connection oriented means handshake. No handshake. Reliable transmission. Reliable transmission means again the handshake. So you'll be sending a acknowledgement every time. There is not a reliable. No, it's here the guarantee of delivery of a packet. Guarantee delivery. Because why guarantee delivery? You have to acknowledge every time. If there is no acknowledgement, retransmission of data, retransmission of packet. But there is no guarantee of delivery. If the packet is failed, there is no retransmission. Got it? And TCP is faster. It is a TCP is fast. Sorry, TCP is slower, and UDP is a faster. Got it? And the UDP will be mostly using for the video conferences. But TCP will be using for all normal regular data exchange, data communications, and file uploads, downloads. So these cases will be used. So any doubts? If you have any questions, this. Any questions? No questions?
Sir, can you just explain once that handshake process?
So you have your computer, right? Computer, and you have your server. This is a Google, whatever it is, Google, Yahoo, Facebook, or whatever it is. So before exchanging of data, you have to perform three-way handshake, right? So for example, If somebody has come to your, some of your, you are in your company, some of your friends, some of your higher people are came to your office. What you have to do, you must perform a handshake with these people. This guy must have to perform a handshake, right? So that is a tradition. So that is a tradition mostly. Whenever your friends also come first, what do you do? So you will not directly talk, right? Most of the cases. So you will just do the handshake, correct? Do the handshake and then start communicating. The same way here, the TCP three-way handshake is before establishing, first you send the synchronization packet. That is the first packet. Server, if the server is ready to accept, okay, if the server is ready to serve, for example, you're trying to access, you type www dot some book called something, some PDF book you're trying to download from the Google. So if the server is ready to share the resources to you, that PDF file, it sends, yes, I am ready to share that information. Okay, so that's why it is acknowledging in the sense. So if someone asks you a question, and if you know the question, if you know the answer, and you what you say, yes, I know that question. So that is the same way like this. And also it also sends another synchronization packet. It comes on a single packet, second packet. So also sends a synchronization packet saying, hey, are you ready to take the data from me? The question, it is asking a question to computer, and the computer, yes, I am. So acknowledging, yes, I am. Got it? And then finally
Yes.
both are agreed. And then start exchanging of data. I mean exchanging, it's not an exchange, it is a from the Google, it is giving to your computer. Okay, so for example, a PDF file which is 20 MB of data. 20 MB is downloaded. Download is completed. Then you will be performing a termination process. Okay, TCP three-way termination. Termination in the sense disconnection between your computer and yeah. So again the same process. So instead of sync, you'll be using a finish. The client is this computer and server now. Computer is sending finish. Okay. Now server is acknowledging, yes, we can finish the session. And it is also sending from, this is the third packet. So it's not the same packet. This is the first, this is the second. The third packet is, it will also send from both the sides finish. It is also acknowledged. So that's how the process works. We'll capture a couple of packets. We'll see in the live, how the packets looks. Okay. We'll see sometime. We'll capture a couple of packets and we'll see inside what is exactly there.
Just
Questions? If no questions, we'll close the session.